So to make 2a with 4a and 2a, we'd want to do 4a take away 2a. So I'm going to put a subtraction symbol in there. To make add 8c, I'd want to add 3c and then add 5c. So, in the second question, I want to make 11d, and I've got a 6d and a 5d, so I would want to add those. So 6d add 5d. To take away 3e, well, 7e take away 4e would give me 3e, but I want to take 3e away. So if I start at taking away 7e and adding 4e, taking away 7 then adding 4 back on would be the same as taking away 3. So my missing symbols are here. So you get 1 mark for having the subtraction and another mark for having the addition in both boxes. So that's your 2 marks. Here you get 1 for knowing that this is an addition here and 1 for both of these being correct, which will give you 2 marks. The nth term of a sequence is 7n add 2. Is 102 in this sequence? Give a reason for your answer. So it isn't in the sequence, so you did have to decide, but the reason being that the nth term rule tells us we have to multiply by 7 and then add 2. So this number 102, if we take the 2 back off, giving us 100, then is there an integer, a whole number, that I can multiply 7 by to make 100? Well, no, because 100 divided by 7 is not an integer. By integer, I mean whole number. Or you could have actually worked out the answer and said no, because 100 divided by 7 equals 14 point, etc. So 1 mark for the saying no and 1 mark for the reason. Okay, so when I recorded this, my screen wasn't showing this table, so I'm just going to re-explain my working. So the expression for 4n when n equals 3 would be 4 times 3, so that would be 12. N squared means n times n. So when n equals negative 5, if I have negative 5, lots of negative 5, then it is the same as 25. So a negative multiplied by a negative is a positive answer. And then finally, we had to work out the missing expression, and we had when n equals negative 5, we get an output of negative 2, and when n equals 3, we get an output of 6. So comparing the input to the output, they are both 3 in difference, so adding 3 to both numbers works. So my expression is n add 3. So Jo made 60 necklaces. It cost £1.20 to make each necklace. She sold 75% of the necklaces for the full price of £5, and she sold the rest at half price. What was her profit? So you make profit by comparing the amount it's cost you to make the item, taken away from the amount you've managed to sell the items for. So if we work out first of all how much it cost her, so the cost is going to be 60 times £1.20, and remember this was calculator paper. Which is £72, and that would be 1 mark. Now you're told she sold 75% of the necklaces. So working out 75%, now either you could know that that is the same as 3/4, so you're finding 3/4 of 60, or to find any percentage of an amount, if you have a Casio, if you type in your percentage, so 75, you press your shift button, which is that button up there, and the left bracket here, then it brings up the percentage. So I want 75% times by 60. So this is a nice percentage to work with, but it works for any percentage. So 45 of her necklaces then, so 75% of 60 equals 45 necklaces. and she sells them for a price of £5. So 45 times 5 equals £225. So at the minute, this is what we would call her earnings so far. So if she sold 25% of the necklaces for the full price, then to sell the other necklaces, that would be the difference between 60 and 45, which is 15. So there were 15 left, which she sold at half price. So half of £5 would be £2.50. So 15 times £2.50 gives us our answer of £37.50. So the total she earned would be the 225 plus the £37.50, which is £262.50. So her profit is her earnings subtract the cost, which is going to be the £262.50 minus the 72, which is equal to £190.50. So evidence of the 75% being 45 necklaces and the remainings being 15 would get you a mark. Working out the earnings of £225 get you another mark and £37.50, so a fourth mark. Subtracting, even if you got your total wrong of £262.50, but you knew you had to subtract the cost, then you get a method mark for that. So we're up to 5 marks and then a final answer mark for your 6 marks in total. Okay, so to solve, it means to find the value of the thing we don't know. So in this case, we don't know what x is, but we do know that a fifth of it, add 8, equals 7. So finding a fifth of something is the same as dividing by 5. So x divided by 5, then adding 8 gives an output of 7. So the opposite of adding 8 would be to take away 8, which would give me -1. And the opposite of dividing by 5 would be to multiply by 5, because we're undoing this process of what's happened to x. So -1 times 5 give me -5, so x equals -5. The other thing you can do here is when you have an equation that involves a fraction, and you can multiply through by 5 so that this no longer has a division of 5, but that makes everything else in the equation 5 times as big. So that would be equal to x plus 40 equals 35. So something add 40 equals 35. So x got to be the difference between your 40 and 35. So x would have to equal -5. So it's an easier route to get there, to get to the answer, but that is from knowing how to handle a fraction within an equation. Second one, again, solve means the same thing. This time we want to know what y equals. 11 take away 15 lots of y equals 6. So that must be the same as 5, because 11 take away 5 equals 6. So 15y equals 5. So y equals 5 lots of divided by 15, which is a fraction that is proper, so it's less than a whole, and they both are divisible by 5, so we can simplify it to 1/3. So y equals 1/3. So it's important to understand with the equations when we solve them that we won't always get integer answers, and they won't always be positive. So we've got a negative here and we've got a non. Okay, so we want to simplify this expression. by collecting the terms what we call like terms, so that they involve the same letter. So here we've got 2/3 of A, and we've got another term, involving A. Then we've got 5/3, add 5/3 of A. So 2/3 add 5/3, leaving with 7/3 of A. Always remembering that the operation before the term shows you what you're doing with it. And so here we've then got taking away 1/4 of B, and then later on taking a further 3/4 of B. So taking away 1/4 and then taking away another 3/4 would be like taking away 4/4. There I have 4/4, I've got a whole thing. So actually that would just be the same as me taking away B. Now you can write 1B there, that's not incorrect. We tend to not write the 1 if we just write the letter, because that implies there is one of it. So you get a mark for getting each part of the expression correct. Okay, so an irrational number, it's a real number that can't be written as a simple fraction. So, for example, this means the cube root of 27. Now, that actually does have an integer solution, because the fact that 3 times 3 times 3 equals 27, so the cube root of 27 is 3. So we can write 3, there's a 3/1, so that would be me writing that as a simple fraction, but just writing 3 is the same thing there. 0.1 recurring, that's what that dot means. That is also a rational number, and the reason it's a rational number is because it can be written as a fraction 1/9, and any recurring decimal can be written as a fraction, so we would then know that that's not irrational. That was already in as a fraction, so that one isn't irrational. And then we've got these two left. So this is a recurring decimal, implied by the repeating digits and the continuation of dots, and so therefore it is this one that is not, and you can test it by putting in your cube root. So you need to press shift cube root of 16, and what you'll see is you will get a decimal. You won't be able to convert to a fraction, it cannot be. It doesn't have any repeating digits, and we aren't able to express that as a fraction. Two numbers have a product of -36 and they have a sum of -5. What are the two numbers? So thinking first of all, product means to multiply. So I want to think of pairs of numbers that multiply to make 36. So we'd have 1 and 36, we'd have 2 and 18 if we were just thinking of multiplying to make positive 36. If we were going to make negative 36, one of them is going to have to be negative. So we'd have 3 and 12, we could have 4 and 9, and we could have 6 and 6. So looking at the sum of them's got to be -5, that's going to mean that there's going to need to be a difference of 5, because one of them's going to have to be negative. So that would be this pairing. As it stands, 4 add 9 makes 13. If I make 4 negative, -4 add 9 would make 5. So it would have to be the 9 that would have to be negative. So -9 add 4 would get me to -5. So there are your two missing numbers. Write 126 as a product. That word product again means multiply of its prime factors. So they are the factors of 126, which are also prime numbers. Remember, prime numbers have exactly 2 factors. So writing out my first few prime numbers, being careful not to make the mistake that 9 is, just because it's the next odd number after this for pattern here, because 9 has got 3 as a factor. Then I want to think of two numbers that multiply to make 126. Now I could have different answers here. The fact it's even, the easiest route would be to half it, so that I have 2 and I have 63. And 2 is a prime number, so I'm going to circle my prime numbers that are therefore factors, prime factors. 63, I know 63 is in my 7 times table, so I'm going to use 7 and 9. 7 being a prime number and therefore a prime factor, and 9 can then be made by doing 3 times 3. And whichever way you chose to split 126 to start with, you should still have ended up with 2, 7, 3 and 3. And so finally, to write 126 as a product of its prime factors, I would need to write them as being multiplied together. So you get 1 mark for at least establishing up to this stage, and then another mark for showing they are the product. So as long as at least 1 prime factor is seen to have been circled and identified, then you would get at least 1 mark.